Hi everyone. I wanted to walk through a problem that was laid out in class today, and that says that this ninja stands a distance of 5 meters here from the center of this platform. R equals 5 meters. The platform starts at rest and starts accelerating in its rotation at 0.5 radians per second squared. There's a coefficient of static friction, and I want to know how long until the ninja is thrown off the platform. Take g equals 10. Well, from this, what we can go ahead and say is, all right, what's going to happen in this situation is that there's actually two components to the acceleration. We're going to have a centripetal acceleration that keeps the ninja traveling on a circular path. And then there's a tangential acceleration, AT, and that's what's actually going to speed the ninja up. And then here is the resulting acceleration vector. So that's a right angle, and so our total acceleration is just the hypotenuse of this triangle. So then the acceleration is going to, from the Pythagorean theorem, that's a radical, is at squared plus ac squared. So remember, the tangential is what's speeding up the ninja, and the centripetal is what's keeping it going in a circular path. And fortunately, from our book, we actually have expressions for all of these. So we can say that this is the square root of tangential acceleration is ar, quantity squared. And then centripetal acceleration is just omega squared times r, all of that squared. Then we take a square root. And then we can go ahead and say, well, we'll do a little bit of algebra, expand that out, and say that this is alpha squared r squared plus omega to the fourth r squared, once I just pass the exponents into the brackets. We don't know omega, but that is actually specified in the problem because we know the angular speed at some given time is the initial angular speed plus alpha times t. And since the platform starts at rest, that is 0. So we know that omega is just equal to alpha times t, and I can come down here and plug that in for my omega. And so from there, we can go ahead and say, all right, well, that is alpha squared r squared plus alpha to the fourth t to the fourth r squared. Now, we need to know what A is in terms of dynamics, and here's where the friction comes in. We know that the friction force is providing this acceleration. It's the platform is moving, and the friction between the platform and the ninja is what's pulling it around in a circle and speeding it up. So we also come over here, and we know that the static friction force is the only force in that direction, is going to be equal to mu s times n. And I've chosen equality here because this is the limiting case. And then from there, we're going to say that that is just mu s times mg. And that's going to give me this expression. And the forces, this is the only force acting in the horizontal direction, that's going to be equal to ma. So now I have a dynamics giving me an expression for the acceleration, so I can actually cancel out the masses of that and get that the acceleration is just mu s times the gravitational constant g. Now, given this acceleration here, which is what the force criterion gives us, and this acceleration here, which is what kinematics gives us, I'll just equate the two of these. And so then I get that mu s times g is equal to the square root of alpha squared r squared plus alpha to the fourth t to the fourth r squared. And from here, I can solve for t. So I'm going to square both sides. So I get mu s squared g squared is equal to alpha squared r squared plus alpha to the fourth t to the fourth r squared. I'm going to go ahead and subtract off this leading term from both sides and divide through by alpha 4 r squared. And I'm going to get that t to the fourth power is equal to mu s squared g squared minus alpha squared r squared over alpha to the fourth r squared. And I can just take the fourth root of that to figure out what the time is. So I'll come on back up here. T is equal to the fourth root of mu s squared g squared minus alpha squared r squared. Alpha to the fourth r squared, all raised to the 1/4 power. And then I just plug in the numbers that are given in the problem. US squared is 0.6. G is totally 10 meters per second squared on Fridays. Both of those are squared. Squared, squared, minus 0.5 rad per second squared times squared times radius to the fourth, radius squared, which is 5 meters squared, all divided by 0.5 radians to the radians per second squared to the fourth power times the radius, which is 5 meters quantity squared. All of these raised to the 1/4 power, and then that comes down. And when I ground it all out, I got 2.1 seconds. Your Ninja may vary. Okay, I hope that helps, and I hope you have a good weekend.